In this video, I want to take a look at the Simplex method from a graphical perspective, this time using a non-standard maximization problem. So I did another video where I looked at this problem. It was a standard maximization problem. The three constraints up here are all less than or equal to, and my objective function 5x plus 6y. And so we ended up with a feasible region down here, right? And so we determined that the optimal solution was this point right here. And I explained how the simplex method starts at the point 0, 0 and moves around the feasible region until it gets to the optimal solution. Well, I'm going to change that standard maximization problem to a non-standard maximization problem by simply taking this third inequality and changing it from less than or equal to greater than or equal to. And that changes everything, because now the feasible region is this area up here outlined by the 4 dots. So when we create our initial table using the simplex method for a non-standard maximization problem that has mixed constraints, the initial table will once again represent the active and inactive variables at the point 0, 0. However, the point 0, 0 is not in the feasible region, right? The feasible region is up here. The point 0, 0 is down here. So the initial table is not even in the feasible region. So our first objective is to create a table that is in the feasible region, that is one of the corners of the feasible region. So the process of getting from the initial table to the feasible region is what I'm calling phase 1. That's the new part of what you're learning how to do now. So that's what phase 1 is. We're starting at 0, 0, and we're working our way to the feasible region. Now, depending on how you select your pivot, remember, sometimes you have different options for how you're going to select your pivot. And so if you select your pivot the best way, then your second table would put you right here. And now that point is in the feasible region. So you would be doing this phase 1 just one time. From the initial table to the first table, you're doing phase 1. Now, let's say you picked a different pivot. Well, that means that the next table might take you over to this corner right here. So table 2 would be right here at the point 3, 0. But you would not be done with phase 1 yet, because you are still not in the feasible region. So you would have to do phase 1 one more time, and that would take you over to this point right here, which is at the corner of the feasible region. So if you selected a pivot one way, you might do phase 1 2 times, from the initial table to table 1, and then to table 2. Now you're in the feasible region. You can start phase 2. Now, regardless of whether you went this way or this way, let's say you went this way, in one step, you got to phase 2. Now, the table down here shows us that the optimal solution is at this point right here. And so if we're at this point, it's going to take us a minimum of 2 more tables in phase 2 to get over here. Or we may end up, depending on how you choose your pivot, you may end up going down this way and then this way. So this is how you can tell how many tables you're going to have. So starting at 0, 0, you have 1 step in phase 1 to get to the feasible region, and then 2 steps in phase 2 to get to the final solution. Even if you went this way, you would have 2 steps in phase 1, and then 1 step in phase 2. And so that's what phase one and phase two are. Phase one is you're getting to the feasible region. Phase two is you're working your way around the feasible region to the optimal solution. So I hope that makes a little bit of sense, kind of give you a visual or a graphical perspective on what you're doing when you're doing this phase one, phase two stuff.